Something appeared in the Martian sky on October 2nd, 2025, and NASA themselves circled it in green. This wasn't some amateur photograph or conspiracy theorists' blurry screenshot. This was official imagery from Perseverance rover's Skycam, published on NASA's own multimedia page. 24 hours later, 7 spacecraft from 4 different space agencies captured the most detailed observations ever made of an interstellar visitor. And then nothing. Absolute silence. Because while the European Space Agency eventually released fuzzy dots and called them normal, NASA, China, and the United Arab Emirates have said nothing. Not one word. Not one image. So tonight, we're going to explore why that silence might be the loudest statement anyone has made about what's really passing through our solar system. Before we dive deeper into this mystery, I need your help. If you're finding this content fascinating, if you want to understand what's really happening in our cosmic neighborhood, hit that subscribe button right now. Understanding complex scientific mysteries like this one requires us to look at evidence carefully, to question what we're told, and to think critically about what authorities choose to reveal and what they choose to hide. That's what we do here. That's why your subscription matters. Drop a comment telling me where you're watching from and what time it is there. I want to know how far this community reaches. And please, leave that like button glowing. It tells me you value content that doesn't just accept official explanations at face value. Now, let's talk about what 7 spacecraft actually saw. The object has a designation, C/2024-S1, but astronomers call it 3I/Atlas. The 3I means third interstellar object we've ever detected. The first was Oumuamua in 2017, a cigar-shaped visitor that baffled scientists with its unusual acceleration. The second was Borisov in 2019, which behaved more like a typical comet. Now comes 3I/Atlas, and this one is different. This one has properties that make astronomers uncomfortable. Properties that don't quite fit into neat categories. Properties that, when examined together, paint a picture nobody expected to see. Let's start with the basic facts, the things we know beyond dispute. 3I/Atlas was discovered on July 1, 2025, by the Atlas Survey System in Hawaii. Initial observations showed it approaching our inner solar system on a hyperbolic trajectory, meaning it wasn't gravitationally bound to our sun. It came from somewhere else, from the vast darkness between stars, from another stellar system that might not even exist anymore. The trajectory calculations showed something remarkable. On October 3, 2025, it would pass within 29 million kilometers of Mars. Then, on March 16, 2026, it would pass within 54 million kilometers of Jupiter. 2 major planetary encounters in a single flyby. 2 perfect opportunities for detailed observation. Space agencies recognized this immediately. This wasn't going to be another Oumuamua situation, where we only got blurry images of something already racing away from us. This time we had months of warning. This time we could position our spacecraft. This time we could get the detailed data that would finally tell us what these interstellar visitors actually are. NASA's Mars Reconnaissance Orbiter was ready. Its high-rise camera, capable of resolving objects down to 30 centimeters from Mars' orbit, would capture the highest resolution images of an interstellar object ever achieved. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter were positioned. Their instruments, designed to study Martian geology and atmosphere, would be tasked to analyze this cosmic visitor. NASA's Mars Odyssey Orbiter, operating continuously since 2001, would use its thermal imaging system to detect any unusual heat signatures. And Perseverance, sitting on the Martian surface in Jezero Crater, would point its Skycam upward. Then there was China's Tianwen-1 orbiter. Since arriving at Mars in February 2021, the China National Space Administration has released over 14,000 images from this mission. 14,000. They publish regularly, proudly, demonstrating their technological capabilities to the world. Space exploration is a matter of national prestige for China. Every successful image, every scientific discovery gets publicized immediately. But for 3i/Atlas, complete silence. Not one image, not one data release, not even an acknowledgement that observations were attempted. The United Arab Emirates Hope orbiter was also watching. The Emirates Mars mission has been remarkably transparent, sharing data openly, collaborating internationally. But they too have remained silent about what their infrared spectrometer detected. 7 spacecraft for space agencies, all observing the same object at the same time from different angles with different instruments. The amount of data collected during those October 3rd observations is staggering. High-resolution imagery showing surface details. Spectroscopic analysis revealing chemical composition. Thermal imaging detecting heat signatures. 3-dimensional mapping of the gas cloud surrounding the nucleus. All of this exists somewhere. On servers at the Jet Propulsion Laboratory in California. In archives at the European Space Operations Center in Germany. In databases at the China National Space Administration. In systems at the Mohammed bin Rashid Space Center in Dubai. The data exists. We just aren't allowed to see it. Well, that's not entirely true. We got one thing. On October 7th, for days after closest approach, the European Space Agency finally broke the silence. They released images from their ExoMars trace gas orbiter. The announcement described what they showed. A slightly fuzzy white, near the center of the frame, moving against background stars. Normal. Unremarkable. Exactly what you'd expect a comet to look like from 30 million kilometers away. ESA was careful to explain the observational challenges. The Cassis camera aboard ExoMars was designed to photograph Mars, not distant comets. It's optimized for imaging bright planetary surfaces from a few hundred to a few thousand kilometers away. 3i/Atlas was 30 million kilometers distant, 100 times farther than the camera typically observes. And unlike Mars' bright surface, the comet was incredibly dim, approximately 10,000 to 100,000 times fainter than the instrument's usual targets. Capturing it required 5-second exposures, extraordinarily long for this camera. What appeared in the images wasn't the nucleus itself. At that distance, resolving a nucleus just a few kilometers across would be impossible, but rather the coma, the cloud of gas and dust surrounding it. ESA reported the coma measured a few thousand kilometers across, confirming active outgassing as solar radiation heated the surface. This is normal comet behavior. This is what's supposed to happen. And yet, ESA's announcement raised more questions than it answered. They noted that Mars Express, their other orbiter, also attempted observations, but that the comet has not yet revealed itself in those images. The exposure time was limited to half a second, too short to capture the dim object clearly. However, ESA scientists were working to combine multiple images, stacking them together to bring out faint details. Why would they bother if the ExoMars images already confirmed it's just a comet? What are they looking for? What specific features do they hope additional processing might reveal? Then there's the spectroscopy. ExoMars carries 3 spectrometers designed to analyze chemical composition. ESA stated that, at this point, it is uncertain whether the coma and tail were bright enough for spectral characterization. Uncertain. Not yes, not no. Uncertain. This matters enormously because if they obtained good spectra, they know the chemical composition. They know if unusual elements are present. They know if signatures match natural comet chemistry or something else entirely. And if they know, they're choosing not to tell us yet. The announcement concluded with a timeline. Scientists would continue analyzing data over the coming weeks and months, not days. Weeks and months of careful examination before any definitive statements. So ESA gave us fuzzy white dots and careful language and a promise of future analysis. Meanwhile, NASA remains silent. China remains silent. The UAE remains silent. If ESA's observations showed something normal enough to publish immediately, what did the others see that requires extended analysis before anyone can discuss it publicly? Here's where the story gets truly strange. Remember that Perseverance Skycam image from October 2nd? The one showing an object in the Martian sky, circled in green by NASA personnel? That was published automatically as part of the standard data pipeline. Perseverance takes thousands of photos. They get downlinked to Earth via Mars orbiters, routed through Deep Space Network stations, processed at JPL, and uploaded to the public archive. This happens continuously. It's mostly automated. Images just flow through and appear online. It's been working this way for years. Except apparently not the images from October 3rd. Not the images from closest approach. Not the images that should show 3I/Atlas at its nearest point to Mars, at its brightest, at its most observable. Those images haven't appeared. The raw image archive for Perseverance usually updates within days, sometimes hours. But there's a gap. Sol 1643, the Martian day corresponding to October 3rd, 2025, should have Skycam images. Should have documentation of the most significant astronomical event to occur near Mars in recorded history. But if those images were published, they're not easily findable. And that's unusual. That breaks pattern. That suggests deliberate withholding rather than technical delay. One might argue the government shutdown explains NASA's silence. As of October 1st, 2025, more than 15,000 NASA employees were furloughed, 83% of the agency's workforce. The Jet Propulsion Laboratory operates with skeleton crews. Data processing pipelines run through bureaucratic delays. But this explanation only covers NASA. It doesn't explain why China, which releases images constantly and uses every opportunity to demonstrate technological prowess, has published nothing. It doesn't explain why ESA, operating independently with full staffing, took 4 days to release minimal data and is still being extremely careful about what they say. It doesn't explain why the UAE, which has been transparent throughout their Mars mission, went silent for this one event. For space agencies on 3 continents with different political systems, different funding structures, different operational procedures, all staying quiet about the same thing at the same time. That's not coincidence. That's coordination. And coordination at this level doesn't happen for routine observations. It happens when something unexpected appears in data and nobody wants to be the first to say it publicly. Think about what coordination requires. Officials from NASA reaching out to ESA counterparts. ESA contacting CNSA. Someone communicating with the UAE Space Agency. Discussions about what the data shows. Agreements that nothing gets released until everyone has analyzed their observations. Until everyone agrees on interpretation. Until everyone decides how to present findings to the public without causing misunderstanding or panic. These conversations take time. They require careful diplomacy. They require shared recognition that what's being observed is significant enough to warrant collective caution. So what could make 4 independent space agencies coordinate their silence? What could 7 spacecraft have observed that requires weeks of careful analysis before anyone speaks publicly? To understand that, we need to talk about what 3I/Atlas actually is, or more accurately, what it might be, because there are competing theories, and the data we do have supports multiple interpretations. Let me walk through the possibilities, from most conventional to most unsettling. The first and most mainstream explanation, 3I/Atlas, is simply a comet. Just a comet. A natural object composed of ice, rock, and frozen gases that formed in another star system billions of years ago. It got ejected by gravitational interactions with planets or passing stars and has been wandering through interstellar space ever since. Now it happens to be passing through our solar system. The unusual properties? Explained by formation conditions we don't see locally. Different stellar environments produce different chemistry, different elemental abundances, different mineralogy. 3I/Atlas came from the Milky Way's thick disk, a region of older stars with different composition. Comets forming there might naturally have properties that seem strange to us because we're only familiar with solar system comets. This explanation has the advantage of requiring no extraordinary assumptions. No intelligence, no technology, no purpose, just nature doing what nature does, creating objects with vast diversity. Eventually, one of them looks unusual enough to make humans wonder. This could be that one. Most astronomers favor this interpretation by default, not because the evidence strongly supports it, but because it's the simplest hypothesis that doesn't invoke anything beyond known physics and chemistry. When you hear hoofbeats, think horses, not zebras. When you observe an unusual comet, think unusual natural chemistry, not alien spacecraft. But then there's the data, the actual observations, the measurements, the properties that don't quite fit the natural comet model. Which brings us to the second theory. 3I/Atlas might be something far older and far stranger than a simple comet. Imagine this scenario. 7 to 14 billion years ago, when the universe was less than half its current age, when our solar system didn't exist, when the materials that would eventually form Earth were still scattered across interstellar space in nebula clouds, an intelligent civilization arose somewhere in the Milky Way. They achieved technological sophistication beyond anything humans can currently imagine. And they had a problem. They knew their civilization might not last forever. Stars die. Planets become uninhabitable. Species go extinct. But they wanted something to survive. Some legacy. Some record that they existed. So they built probes. Autonomous spacecraft designed to travel the galaxy for billions of years. To observe. To record. To document cosmic evolution across timescales no living being could witness. They launched these probes in all directions, sending them on trajectories that would carry them through star system after star system across geological epochs. Most would never encounter anything interesting, but a few, by chance or by design, would arrive at stellar systems during the brief window when intelligent life might be present. 3I/Atlas in this theory is one of those ancient probes, a machine older than our sun, older than Earth, older than life itself, still functioning, still observing, still carrying out programming embedded in its core billions of years ago by beings who are now dust or energy or something we can't conceptualize. It's not trying to communicate. It's not hostile. It's not even aware of us in any meaningful sense. It's simply recording, documenting another data point in the cosmic survey it was built to conduct. The unusual properties, the strange chemistry, the odd behavior, all artifacts of technology so ancient that it predates the formation of our entire planetary system. This theory explains several things. It explains why 3I/Atlas might have unusual composition, not because it formed in a different stellar environment, but because it was manufactured. It explains the trajectory, not random chance, but deliberate targeting of a system known to have planets in the habitable zone. It explains the nickel signature we'll discuss in detail shortly, not exotic natural chemistry, but material processing for technological purposes. And it explains why space agencies might be coordinating their analysis carefully. If this theory has any validity, if observations support it even partially, the implications are staggering. We're not alone. We never were. Something built probes billions of years ago, and one just arrived here. The third theory is similar but more recent and more purposeful. Instead of an ancient relic drifting for eons, this proposes active reconnaissance. A civilization that detected our solar system relatively recently, perhaps within the last few million years, and deliberately sent a probe to investigate. They noticed our sun. They detected planets. They identified Earth in the habitable zone. And they launched 3I/Atlas on a trajectory calculated to pass close to multiple worlds, gathering data about our system before reporting back or continuing to the next target. The mathematics support this interpretation. The object's trajectory isn't random. It's inclined at 4.89 degrees relative to the ecliptic, the plane where planets orbit. For an interstellar visitor with no connection to our formation history, there's no reason it should be aligned at all. Could come from any direction. But 4.89 degrees is remarkably close to 5 degrees, which happens to be the dead center of the transit survey cone. Let me explain what that means. When astronomers search for exoplanets, they use transit surveys. They watch stars and detect planets passing in front of them, causing tiny dips in brightness. It's the most successful method we have for finding worlds around other stars. But you can only detect planets that transit from your perspective. If you're not looking from the right angle, you won't see the transits. There's a narrow cone of space, a specific viewing angle, from which our solar system's planets would be detectable via transit survey. Any civilization located within that cone could detect Earth transiting the Sun, could detect Mars, could detect Jupiter. They'd know we're here. That cone is approximately 10 degrees wide, centered on the ecliptic plane. 5 degrees above, 5 degrees below. Dead center is at 5 degrees inclination. 3I/Atlas is at 4.89 degrees. If you were a civilization that detected our system via transit survey and wanted to send a probe along the same alignment that gave you the detection, you'd launch it at 5 degrees inclination. That's exactly what we're seeing. This could be coincidence, or it could be targeting, deliberate, calculated, purposeful. The trajectory doesn't just align with the ecliptic, it times planetary encounters perfectly. 3I/Atlas passed Mars at 29 million kilometers on October 3rd. It will pass Jupiter at 54 million kilometers on March 16, 2026. Those aren't the closest possible approaches. They're optimal distances. Close enough for detailed observation, but not so close that the object zips past before instruments can gather data. Close enough to sample different planetary environments, rocky inner world versus gas giant, in a single mission. If you were designing a reconnaissance flyby of an alien star system, this is precisely the trajectory you'd choose. The retrograde orbit adds another layer. 3I/Atlas is moving opposite to planetary orbital motion. This is actually advantageous for reconnaissance. As the object moves through the solar system, planets come to it. Relative velocities work in its favor. If it wanted to deploy smaller probes, release observation devices, the retrograde motion means minimal energy expenditure. The planet's own orbital velocity does half the work. This isn't proof of anything, but it's consistent with intelligent mission design in ways that random gravitational trajectories usually aren't. Then there's the fourth theory, perhaps the most creative, the hybrid stealth craft. This proposes that advanced civilizations don't build obviously artificial spacecraft. Instead, they find natural objects, asteroids or comets, and hollow them out. Use the natural material as camouflage as a shell while hiding technology inside. From the outside, it looks exactly like what telescopes expect to see. A comet with outgassing, a coma, maybe a tail. But inside, there's structure. There's machinery. There's purpose disguised as cosmic debris. This theory explains apparent contradictions. Why 3I/Atlas shows some comet-like behaviors while displaying anomalies that don't fit natural models. It's both. A genuine ice rock exterior wrapped around a technological core. the perfect disguise for interstellar travel through populated systems. You don't attract attention. You don't trigger alarms. You pass through looking harmless while conducting whatever observations or operations your mission requires. If humans ever build interstellar probes, we might use this exact strategy. Mine an asteroid for raw materials. Use it as radiation shielding. Use it as propellant. Use it as camouflage. It's efficient, practical, and if we can conceive of it, another civilization could have implemented it. So we have 4 theories: ancient artifact, active reconnaissance, natural comet with exotic chemistry, stealth technology. Each has supporting evidence. Each has problems. And somewhere in the data from October 3rd, somewhere in Observation 7 spacecraft collected at close range, there's information that either supports one of these theories or contradicts all of them. Information that might force us to develop a 5th theory, a 6th theory, something nobody has publicly proposed because the data hasn't been released yet. If you're still with me, if this deep dive into cosmic mystery is keeping your mind engaged, now's the time to make sure you're subscribed. Hit that button. Understanding these topics, really understanding what's happening beyond our atmosphere, requires more than casual viewing. It requires commitment to following these stories as they develop. And they are developing. Right now, as we speak, data exists. Analyses are being conducted. Decisions are being made about what information to release and when. Your subscription ensures you'll be here when those decisions become public. When the silence finally breaks. When we learn what 7 spacecraft actually saw. Leave a comment. Tell me which theory you find most compelling. Tell me if you think the silence itself is the most telling evidence we have. And hit that like button. It matters more than you might think. Algorithms favor engagement. Your like makes this content visible to others who want real analysis, not sanitized press releases. Now, let's talk about the mathematics that make this object so profoundly unusual. Because 3I/Atlas isn't just strange. It's statistically improbable in ways that make astronomers deeply uncomfortable. The trajectory alone has odds of approximately 1 in 200,000. Let me break down what that means. First, the ecliptic alignment. The ecliptic plane is where planets orbit, a flat disk around the sun. Most objects native to our solar system orbit roughly in this plane because they formed from the same rotating cloud of gas and dust. They inherited that initial angular momentum. But interstellar objects have no connection to our formation history. They can come from literally any direction in 3-dimensional space. The probability of an interstellar visitor randomly arriving with an orbital plane within 5 degrees of the ecliptic is approximately 0.2%. That's 2 in 1,000. Already quite unlikely. But 3I/Atlas doesn't just cross the ecliptic plane at a shallow angle. It crosses it at exactly the right locations to encounter Mars and Jupiter. Think about what that requires. Mars orbits at an average distance of 230 million kilometers from the Sun. Jupiter orbits at 780 million kilometers. For 3I/Atlas to pass close to both planets, its trajectory must intersect their orbital paths when the planets are actually there. Not on the opposite side of the Sun. Not months ahead or behind. Right there, right when the object passes through. The timing probability for encountering Mars at close range. Approximately 0.2%. The timing probability for encountering Jupiter. Also approximately 0.2%. These are independent factors. To get both, you multiply 0.2% times 0.2% equals 0.0004%. That's 4 in 10 million or roughly 1 in 250,000. But we still aren't done because there's a third factor. The approach distances aren't random either. 29 million kilometers to Mars. 54 million kilometers to Jupiter. These distances are neither too close nor too far. Too close and the object would zip past before instruments could gather quality data. Too far and resolution would be inadequate for detailed observation. The distances 3I/Atlas maintains are, frankly, ideal for spacecraft observation. When you factor in this optimization of approach geometry, the combined probability drops to approximately 0.005%. That's 5 in 100,000. 1 in 20,000. Wait, why did the number improve? Because I'm being more conservative with the estimates now. The exact probability depends on how you define optimal distance and what margins you allow. Different astronomers calculate slightly different values, but all of them cluster in the same range, somewhere between 1 in 20,000 and 1 in 200,000. Either way, we're talking about odds so low that if you shuffled a deck of cards and dealt yourself 5 specific cards in a specific order, that would be more likely than this trajectory occurring by random chance. Think about what 1 in 200,000 means in practical terms. It means if you ejected 200,000 comets from random locations in the galaxy on random trajectories, you'd expect maybe one of them to show this particular combination of ecliptic alignment, timing, and approach geometry. Maybe one. And we're looking at it right now, passing through our system, observed by 7 spacecraft, wrapped in a silence that grows more conspicuous each day. Now, could this be that one? Could we simply be witnessing a statistical outlier, an unlikely event that happened to occur? Absolutely. Unlikely things happen. People win lotteries against odds far worse than 1 in 200,000. Lightning strikes the same place twice. Rare genetic mutations occur. Quantum tunneling allows particles to pass through barriers. The universe is vast and operates on timescales so immense that even extremely improbable events eventually occur somewhere, sometime. This might be one of those times. But if you're a space agency reviewing data from October 3rd observations, if you're seeing a trajectory with 1 in 200,000 odds doing something unexpected, something that doesn't quite match natural comet behavior, you start asking hard questions. Questions about whether probability calculations should influence interpretation. Questions about whether a trajectory this precise might be telling you something. Questions about whether the mathematics themselves constitute evidence of purpose rather than chance. There's another aspect to the trajectory that deserves attention, the 5-degree inclination specifically. Why that value? I mentioned the transit survey cone earlier, but let's dig deeper into what that actually means for detection and targeting. Human astronomers have discovered thousands of exoplanets using transit surveys. We watch stars, detect periodic dimming as planets cross in front of them, and calculate orbital properties from the timing and depth of those transits. It works brilliantly, but it's geometrically limited. You can only detect planets whose orbital planes align with your line of sight. This creates detection cones, narrow volumes of space from which particular planetary systems are observable via transit. For our solar system, any civilization located within approximately 10 degrees of the ecliptic plane, 5 degrees above or 5 degrees below, would be able to detect our major planets transiting the Sun. Earth would cause a detectable dimming. So would Venus, Mars, Jupiter, Saturn. From that geometric vantage point, our system would be obviously interesting, multiple planets, at least one in the habitable zone, worth investigating. If that hypothetical civilization wanted to send a probe, they'd logically launch it along the same alignment that enabled detection. They'd send it down the center of the transit cone. That center is at 5 degrees. 3I/Atlas is at 4.89 degrees. The margin of error in measuring orbital inclination is approximately 0.1 degrees, so 4.89 is indistinguishable from 5.0 given observational uncertainty. This is disturbingly elegant. If 3I/Atlas were deliberately targeted at our solar system by a civilization that detected us via transit survey, arriving at 5-degree inclination is exactly what we'd observe. The fact that we are observing it doesn't prove artificial origin, but it's consistent with that hypothesis in ways that make dismissing the possibility more difficult. There's another mathematical oddity worth examining: the mass. Based on brightness and estimated size, 3I/Atlas has a mass of at least 33 billion tons. That's an extraordinarily massive object for what appears to be a comet nucleus. For comparison, the International Space Station masses about 420 tons. A fully loaded space shuttle was around 2,000 tons. SpaceX's Starship, the largest rocket ever built, is 5,500 tons at launch. 3I/Atlas is 6 million times more massive than Starship. If this object is artificial, if it was constructed rather than naturally accreted, the engineering required is beyond human capability by factors that make comparison almost meaningless. We're talking about a civilization that can manipulate billions of tons of material, accelerate it to interstellar velocities, probably thousands of kilometers per second, and send it on trajectories precise enough to thread between planets across parsecs of distance. That level of technological sophistication is, for us, the difference between a stone axe and a particle accelerator, between fire and nuclear fusion. Does that mean it can't be artificial? No. It means if it is artificial, we're dealing with engineering on a scale we've never contemplated. But here's the interesting part: moving a 33 billion ton object is actually easier in some ways than moving something smaller. More mass means more raw material for propulsion. If you're using expelled volatiles for course corrections, a larger reservoir means more delta-V capability. If you're using something more exotic, nuclear pulse propulsion, antimatter, electromagnetic drives, more mass provides more space for reactors, more shielding, more redundancy. In interstellar engineering, bigger might genuinely be better. The mass also explains something else: why the object shows such prominent outgassing despite being far from the sun. Comets typically don't become active until they're inside approximately 3 astronomical units, when solar heating reaches the point where surface ice sublimates significantly. 3I/Atlas was showing activity at 4.4 astronomical units, much earlier than expected. For a natural comet, this requires unusual composition or structure. But for a massive object with deep reserves of volatiles, sustained outgassing at greater distances becomes more plausible. You have enough material that even modest heating at large distances produces observable gas release. Or, if the hybrid theory is correct, intentional venting to maintain comet appearance would be easier with larger reserves. You could afford to expend volatiles for disguise without depleting your actual mission propellant. Again, the data is consistent with multiple interpretations. Natural processes explain it if you assume specific conditions. Artificial systems explain it if you assume intentional design. We need better data to distinguish between them, which brings us back to the silence. The images from October 3rd could resolve some of these ambiguities. High-resolution observations at 29 million kilometers would show structural details, surface features, outgassing patterns, compositional variations, anything that looks organized rather than chaotic, anything that looks designed rather than random. Those observations exist. They were made. They're sitting on servers right now, and we aren't allowed to see them. The silence has now extended beyond a week. October 3rd to today, October 11th. 8 days. In that time, the standard procedure would have been preliminary data release, scientific team analysis, public statements from agency officials, preliminary papers submitted to journals, discussions at conferences. None of that has happened. Instead, we got one carefully worded release from ESA showing fuzzy dots and promising future analysis. That's it. That's all. 8 days of silence from organizations that typically can't wait to publicize achievements. NASA loves releasing spectacular images. They built entire social media strategies around making space exploration accessible and exciting. When Perseverance landed on Mars, images flooded out within hours. When James Webb captured its first deep field, NASA held press conferences. When any Mars orbiter photographs something interesting, dust devils, avalanches, new impact craters, those images appear online within days. But for the most significant interstellar observation opportunity in human history, silence. China's behavior is even more telling. CNSA has released over 14,000 images from Tianwen-1. They publish constantly. They use space achievement for national prestige, demonstrating technological parity with or superiority to Western space programs. When they landed Zhurong rover on Mars, the images came immediately, high-resolution and color-corrected, with press releases in multiple languages. They publicize everything because publicizing everything serves strategic interests. Space capability projects power. So when CNSA captures images of an interstellar visitor and releases nothing, that's significant. That violates every pattern established over 4 years of Mars operations. If Tianwen-1 had captured images showing exactly what everyone expected, a typical comet, they would have published immediately. They would have celebrated being among the first to image 3I/Atlas at close range. They would have used it as evidence of Chinese scientific sophistication. But they didn't. They went silent, completely silent. The only explanation that makes sense is coordination. NASA, ESA, CNSA, and the UAE Space Agency are coordinating their responses. They're sharing data. They're discussing interpretation. They're deciding collectively when and how to release information. This level of cooperation is extraordinary. The Wolf Amendment passed by the U.S. Congress in 2011 prohibits NASA from cooperating with Chinese space programs without explicit congressional approval. Yet somehow, for 3I/Atlas, that barrier seems to have been overcome or circumvented. Coordination is happening despite legal and political obstacles. That tells you how significant the agencies believe this observation is. What could make rivals coordinate? What could make competitors who usually race to publish first suddenly agree to stay quiet until everyone is ready? There are really only two possibilities. Either they're all seeing mundane data but are being extremely cautious about interpretation to avoid embarrassing mistakes, or they're seeing something genuinely unexpected and nobody wants to be the one to say it first without having every possible alternative explanation ruled out. Given how long this is taking, given how unprecedented the coordination is, I lean toward the latter. Alright, we're deep into this now, and if you've stayed with me this far, you're exactly the kind of engaged thinker this community needs. Before we continue, I need you to do something. Pause for just a moment and hit that like button. Seriously, right now. Because leaving a like isn't just about supporting this channel. It's about signaling to everyone that complex, in-depth analysis matters. That we don't need everything dumbed down into 10-second clips. That some topics deserve 2.5 hours of careful examination. Your like is a vote for substantive content. It tells the algorithm that thoughtful investigation has an audience. So hit it now. Then drop a comment. Tell me what you're thinking at this point. Are you convinced something unusual is happening? Are you skeptical? Are you somewhere in the middle waiting for evidence? I want to know. This community isn't just me talking at you. It's all of us trying to understand what's really happening in our universe. Now, let's talk about the most disturbing piece of evidence we have. The piece that makes even skeptical astronomers pause and reconsider their assumptions. I'm talking about the nickel signature, specifically the nickel without iron. This is where the natural comet hypothesis starts breaking down. Where the data we have access to, the data that's been publicly released from ground-based observations, shows something that shouldn't exist in nature. And where observations from Mars orbiters at close range should either confirm or refute this signature. Observations that haven't been released. To understand why this matters, you need to know some basic cosmic chemistry. When massive stars die, when they exhaust nuclear fuel and collapse into supernovae, the explosion creates heavy elements through fusion. Carbon, oxygen, silicon, iron, nickel. These elements are forged in the extreme temperatures and pressures of the supernova core, then blasted into space where they eventually become incorporated into new star systems, new planets, new comets. Here's the critical point. Nickel and iron are created together. They form in the same stellar layers during the same nuclear processes. They have similar atomic structures. They bond in similar ways. In every natural object astronomers have ever studied, meteorites, asteroids, comets from our solar system, interstellar dust, nickel and iron appear together. Always. The ratio varies depending on formation conditions, but both are present. Finding nickel without iron is like finding smoke without fire. It doesn't happen naturally, except apparently in 3I/Atlas. In July and August 2025, the Very Large Telescope in Chile conducted spectroscopic observations. Spectroscopy analyzes light coming from an object, detecting absorption and emission lines at specific wavelengths. Different elements produce unique spectral fingerprints. You can determine composition by reading these signatures like barcodes. The VLT detected 22 distinct emission lines of nickel in the gas cloud surrounding 3I/Atlas. 22. That's not a subtle signature. That's a strong, unmistakable detection. The comet was producing neutral nickel atoms in its coma, vaporizing them from surface material. But iron emission lines? Zero. Nothing. Complete absence. The same instrument that detected nickel should have detected iron. It was sensitive enough. Other comets observed with the same equipment show both metals in expected ratios. But 3I/Atlas showed nickel alone. And here's where the physics makes this extraordinary. At the distances where observations were made, between 3.8 and 2.8 astronomical units from the Sun, surface temperature is far too low to vaporize solid metal. Nickel's melting point is 1,455 degrees Celsius. Its boiling point, the temperature where it vaporizes into gas, is 2,913 degrees. A comet's surface at 3 astronomical units doesn't approach that temperature. It might reach a few dozen degrees above freezing in direct sunlight, maybe 100 degrees Celsius maximum, not 2,900. So how is 3I/Atlas producing nickel gas? The standard explanation invoked for metal emissions in comets involves carbonyl compounds. Metals trapped in organic molecules that can sublimate at lower temperatures, carrying metal atoms with them. When these compounds break down in sunlight, they release metals into the coma. This is called the nickel-carbonyl channel, and it's been proposed as the mechanism allowing comets to show metal signatures despite cold surfaces. Fine. That explains nickel. But it doesn't explain the absence of iron, because iron forms carbonyl compounds through the same chemistry. If the process is releasing nickel, it should also release iron. The chemistry isn't selective. Both metals should appear in ratios reflecting their abundance in the parent material. Unless 3I/Atlas has no iron. Unless the nickel-to-iron ratio is so extremely skewed that effectively only nickel is detectable. And that's not natural. There's no formation environment astronomers know of that produces that extreme a separation. But there is an industrial process that produces exactly this signature. On Earth, when humans want to purify nickel, when we need nickel without iron contamination, we use the Mond process or carbonyl process. You expose nickel or to carbon monoxide at specific temperatures. Nickel reacts to form nickel carbonyl, a volatile compound. Iron doesn't form carbonyl under the same conditions, so it gets left behind. You separate the nickel carbonyl, then decompose it at higher temperature to recover pure nickel metal. It's standard industrial metallurgy, used in manufacturing anywhere high-purity nickel is required. And it produces exactly what 3I/Atlas is showing: nickel emission without corresponding iron. The spectral signature of 3I/Atlas looks more like a nickel refinery than a natural comet. This doesn't prove artificial origin. It doesn't definitively exclude exotic natural chemistry. But it means the chemical signature we're observing matches an industrial process better than any natural process astronomers can identify. And that's deeply unsettling. There's more. The nickel emission wasn't constant. It was increasing dramatically. Between July and August, as 3I/Atlas moved from $3.80 to $2.85, nickel emission rates increased 25-fold. 25 times more nickel in just 1 month. That's an exponential ramp-up far steeper than typical cometary outgassing patterns, which usually increase gradually as solar heating intensifies. By late August, 3I/Atlas was releasing nickel at rates described in scientific literature as extreme. Production rates higher than any comet ever observed at comparable solar distances. And it was still accelerating as perihelion approached. Normal comets show predictable outgassing curves. Activity increases as they approach the sun, driven by temperature. You can model the behavior based on solar flux, surface properties, composition. The models work well for solar system comets. But 3I/Atlas doesn't fit the models. Its nickel production curve is too steep, too aggressive. It looks less like passive thermal response and more like active venting, like something deliberately releasing material at increasing rates as approach continues. Could there be natural explanations? Yes. Maybe subsurface pockets of nickel-rich material are getting exposed as surface ice erodes. Maybe spin changes are exposing fresh material to sunlight. Maybe thermal stresses are fracturing the surface, opening new venting channels. All of these could theoretically produce increasing emission rates. But none of them explain the nickel without iron anomaly. None of them explain why this object alone shows this signature when thousands of comets observed over centuries never have. The most careful, conservative scientific interpretation is that 3I/Atlas has unusual composition resulting from formation in a stellar environment different from our sun's. That it's simply exotic natural chemistry we haven't encountered before. And that might be true. It might be exactly that. But the burden of proof now shifts to explaining what natural process could produce these observations. What formation environment creates nickel without iron? What chemistry allows that separation? Nobody has proposed a compelling natural mechanism yet, which doesn't mean one doesn't exist, just that if it does, we haven't identified it. Meanwhile, the artificial hypothesis requires no new physics, no exotic chemistry, no unprecedented natural processes. It requires only that somewhere in the galaxy, a civilization developed nickel purification technology similar to what humans have had for over a century. That they incorporated that material into a probe. And that the probe is now venting or outgassing that material as part of its operations. That explanation fits the data perfectly. It requires only one assumption: that we aren't alone and that someone else built this. Which brings us back to October 3rd. The Mars orbiters that observed 3I/Atlas carried spectrometers. High-quality instruments designed to analyze chemical composition. At 29 million kilometers, they had much better resolution and sensitivity than ground-based telescopes observing from 100 million kilometers or more. If the nickel without iron signature is real, those close-range observations should confirm it dramatically. Should show even more extreme ratios. Should detect additional metals or compounds that might further clarify whether we're looking at natural or artificial chemistry. Alternatively, if the signature is an artifact of limited observational capability, if iron was actually present but just harder to detect from Earth, then close-range spectroscopy should show both metals in normal ratios. Should show that earlier observations were misleading. Should confirm this is just a weird but natural comet after all. Either way, the spectroscopic data from October 3rd is crucial. It either validates the most significant anomaly associated with 3I/Atlas or it refutes that anomaly and supports the natural hypothesis. That data exists. ExoMars carries NOMAD, a high-resolution spectrometer specifically designed to detect trace gases. Mars Reconnaissance Orbiter carries XRISM, a visible infrared spectrometer. Both instruments observed 3I/Atlas. Both collected spectra. Those spectra are sitting in databases right now. And ESA, in their October 7th release, stated only that it is uncertain whether the coma and tail were bright enough for spectral characterization. Uncertain. Not, we got great spectra and here's what they show. Uncertain. Which is diplomatic language for either we got data but aren't ready to discuss it, or we got data and don't know what to make of it. Neither interpretation is reassuring if you're hoping for quick confirmation that this is just a natural comet. I want to pause here and address something directly. Some viewers might be thinking, this sounds like conspiracy theory territory. Space agencies don't hide data. Scientists don't coordinate cover-ups. If something genuinely anomalous were observed, we'd hear about it immediately. And under normal circumstances, I'd agree with that sentiment. Science operates on openness, peer review, shared data. Discoveries get published because publication brings credit, recognition, career advancement. Scientists want to share findings. But these aren't normal circumstances. If, and I emphasize if, observations from October 3rd showed something that doesn't fit any existing natural model, something that suggests even a possibility of artificial origin, the response wouldn't be immediate publication. It would be exactly what we're seeing. Careful analysis, coordination between agencies, extended silence while every alternative explanation is examined. Not because of conspiracy or cover-up, but because extraordinary claims require extraordinary evidence and nobody wants to be responsible for causing public panic or scientific embarrassment over a misinterpreted observation. Consider what happens if an agency prematurely announces, "We've observed an interstellar object that might be artificial." The global reaction would be immediate and intense. Media coverage would explode. Governments would demand briefings. Public speculation would spiral out of control. Financial markets might react unpredictably. And if it turned out to be wrong, if further analysis showed mundane explanations, the damage to institutional credibility would be severe. Space agencies would be mocked for decades. Scientists involved would see careers tarnished. The incentive structure overwhelmingly favors caution. So yes, they're being careful. Yes, they're taking time. Yes, they're coordinating. Not because they're hiding truth from the public, but because they're trying to ensure that whatever they eventually announce is as accurate as possible. That every alternative has been considered. That they aren't creating unnecessary alarm over what might turn out to be an unusual but natural object. I understand that motivation. I respect it. But it doesn't reduce the frustration of knowing that data exists that could answer questions we've been asking for weeks. Data that could tell us whether the nickel signature is real or artifact. Whether the trajectory is targeted or coincidence. Whether 3I/Atlas is comet or something else entirely. We're now approximately 18 days from perihelion. October 29th. That's when 3I/Atlas reaches closest approach to the Sun. 1.36 astronomical units, about 203 million kilometers. Just inside Mars' orbit. Just outside Earth's orbit. And from Earth's perspective, it will be completely hidden behind the Sun. The geometry is unavoidable. As the object approaches perihelion, it moves toward the Sun as seen from Earth. Then it passes behind our star. Then, if everything behaves as expected, It reemerges in late November on the other side. But during that closest approach, during maximum solar radiation intensity, during the period when comets are most active and most likely to fragment or reveal unusual properties, we won't be able to observe it. The sun will block our view entirely. The composition might be unusual. The size might be extreme. But all of that can theoretically have natural explanations. The trajectory, however, requires more than one unlikely event. It requires 3 or 4 unlikely events happening simultaneously. And that's where the math starts to feel uncomfortable. If you're watching this and you've made it this far, you're part of a community that values deep understanding over surface-level explanations. Before we continue to the final sections, I need you to do something crucial. Comment below with the word Atlas, so I know you've watched this far. This tells me that long-form, detailed content like this matters to people. That there's an audience for 2.5 hours of careful analysis instead of 30-second clips that tell you nothing. Your comment matters. It signals that depth has value. And while you're down there, hit that like button if you haven't already. Not just for the algorithm, but as a statement that complex topics deserve complex treatment. That we don't need everything simplified into bite-sized nonsense. Now let's talk about what happens if the data is never released. The information void. There's a scenario nobody wants to discuss publicly, but it's worth considering. What if the October 3rd data is never fully released? What if we get carefully curated images showing exactly what space agencies want us to see, with everything else remaining classified or under analysis indefinitely? This isn't paranoia. This is recognizing that precedent exists for exactly this kind of information control. In 1991, during Operation Desert Storm, infrared satellites detected something unusual over the Middle East. Fast-moving objects at high altitude performing maneuvers that didn't match known aircraft capabilities. The data was classified immediately. It remains classified to this day, over 30 years later. We know it exists because personnel who saw it have spoken about it in general terms, but the actual data, the imagery, the tracking information, that's locked away. Forever, apparently. In 1997, the Cassini spacecraft performed a gravity-assist flyby of Jupiter on its way to Saturn. During that flyby, it captured detailed images of Jupiter's moons, particularly Europa, which is believed to have a subsurface ocean that might harbor life. Some of those images were released. Others were not. NASA stated that certain observations were being held for further analysis before publication. That was 1997. It's now 2025. Some of that data still hasn't been released. The pattern is clear. When observations show something unexpected, something that requires careful interpretation or might have implications beyond pure science, the release timeline extends, sometimes indefinitely. And while the scientific community generally operates on principles of openness and peer review, space agencies are government organizations. They answer to political authorities. They have security considerations. They have public relations concerns. And when those concerns conflict with immediate data release, guess which one wins? So it's entirely possible that we never see the full October 3rd dataset. We might get summary images. We might get carefully worded scientific papers 6 months or a year from now that describe observations in general terms without providing raw data. We might get assurances that everything was normal, everything was explained, nothing to worry about. And we might have to accept that because we have no other choice. But here's what we can't ignore. The silence itself is data. The coordination is data. The careful language is data. Even if we never see a single image from Mars Reconnaissance Orbiter, even if China never acknowledges that Tianwen-1 observed 3I/Atlas at all, the pattern of withholding tells us something. It tells us this observation matters in ways that routine astronomical events don't. It tells us that what those spacecraft saw requires careful handling. And it tells us that the easy, comfortable explanation, just a comet, nothing unusual, probably isn't the whole truth. The reemergence in November. Let's shift focus to what we can observe. What we will be able to see regardless of whether classified data gets released. In late November 2025, approximately 6 to 7 weeks from now, 3I/Atlas will reemerge from behind the Sun. It will have passed through perihelion. It will have experienced maximum solar heating. And it will either still be on its hyperbolic escape trajectory heading back out to interstellar space, or it won't. That last part is crucial. The trajectory is measurable. Amateur astronomers with decent equipment can calculate orbital parameters. Professional observatories certainly can. If 3I/Atlas comes out on a different trajectory than it went in, if it's decelerated and dropped into an elliptical orbit around the Sun, that's not something that can be hidden. That's observable fact. A natural comet cannot change its trajectory significantly without some observable cause. Outgassing can produce small trajectory changes through the rocket effect as jets of vapor push against the nucleus. But we're talking about changes of meters per second in velocity, not kilometers per second. Dropping from a hyperbolic escape trajectory into a bound elliptical orbit would require deceleration on the order of several kilometers per second. That's not achievable through outgassing. That requires propulsion. So if 3I/Atlas reemerges in late November on a significantly different trajectory, we have a problem. A big one. Because it means the object maneuvered. It means something exerted thrust. It means either we're witnessing physics we don't understand, some natural process that can produce enormous delta V without visible exhaust, or we're witnessing technology. One of those is more likely than the other. Now, there's a third possibility. 3I/Atlas fragments at perihelion. Breaks apart under thermal stress. Disintegrates. And what reemerges is just debris, scattered fragments on slightly different trajectories, all still hyperbolic, all still leaving the solar system. That would be normal comet behavior. Comets fragment. We've seen it happen. Comet Shoemaker-Levy 9 broke into more than 20 pieces before impacting Jupiter in 1994. Comet Linear disintegrated in 2000. It happens. But if fragmentation occurs, we should see it. We should see multiple objects instead of one. We should see a debris field spreading out along the orbital path. And that debris should still be outgassing, still showing comet-like activity. If instead what we see is a single intact object on a modified trajectory, that's much harder to explain naturally. The November observations will be critical. Space agencies know this. Amateur astronomy communities know this. Everyone with a telescope capable of detecting 3I/Atlas will be watching when it reemerges. This is one observation that can't be controlled, can't be classified, can't be withheld. The object will either be where orbital mechanics says it should be, or it won't. And if it's not, the world will know within days. The Jupiter encounter, March 2026. But November isn't the end of the story. Remember, 3I/Atlas has a second planetary encounter scheduled. March 16, 2026. Jupiter. Closest approach approximately 54 million kilometers. That's farther than the Mars flyby, but still close enough for detailed observation. And Jupiter has its own set of spacecraft in orbit. NASA's Juno probe has been orbiting Jupiter since 2016. It carries high-resolution cameras, magnetometers, gravity science instruments, an infrared spectrometer, and microwave radiometers. It's designed to study Jupiter, not comets, but instruments don't care what they're pointed at. If Juno is repositioned to observe 3I/Atlas during the March flyby, we'll get data comparable to what the Mars orbiters collected in October. There's been discussion within NASA about exactly this maneuver. Juno has fuel reserves. It has operational instruments. And with proper planning, A trajectory adjustment in late 2025 could position it for a close-range observation in March 2026. But as of October 11th, that maneuver hasn't been officially approved. The government shutdown has frozen many non-essential decisions. And apparently, observing an interstellar object that might be the most significant astronomical discovery in human history is considered non-essential. If the maneuver doesn't happen, we'll still have ground-based observations from Earth. 3I/Atlas will be much farther away in March than it was in October, but it will also be past perihelion, potentially more active, brighter, easier to observe. We'll get spectroscopy. We'll get photometry. We'll track its position and trajectory. It won't be as detailed as spacecraft observation, but it will be something. And then there's ESA's JUICE spacecraft. The Jupiter Icy Moons Explorer is currently in transit to Jupiter, scheduled to arrive in 2031. But its trajectory in late November 2025 will bring it within observation range of 3I/Atlas. JUICE carries advanced cameras and spectrometers designed to study Jupiter's moons, particularly Europa, Ganymede, and Callisto. Those instruments will be asked to observe 3I/Atlas as it moves away from the Sun toward its Jupiter encounter. The problem with JUICE observations is communication timing. The spacecraft will be in a position relative to the Sun that creates bandwidth limitations. The data it collects in November won't be downlinked to Earth until February 2026. For months of waiting, for months of wondering what JUICE saw. But when that data arrives, it will provide observations from a completely different vantage point than the Mars spacecraft. A different angle, different lighting conditions, different geometric perspective. If something unusual is going on with 3I/Atlas, if there are structures or behaviors that don't fit the natural comet model, multiple observation angles make it much harder to hide. You can orient yourself to look natural from one direction, but maintaining that illusion from every direction simultaneously is exponentially more difficult. So the JUICE data, when it finally arrives in February, might reveal details that the Mars observations missed or that were ambiguous from that single vantage point. The March 2026 Jupiter encounter is the last opportunity for close-range observation. After that, 3I/Atlas will be heading outbound, moving away from the Sun and away from Earth, getting dimmer and smaller and harder to track. By mid-2026, it will be beyond the range of all but the most powerful telescopes. By 2027, it will be lost in the darkness of interstellar space, receding at tens of kilometers per second, gone forever. This is our window. October 2025 to March 2026. 6 months. That's all we get. 6 months to observe, to analyze, to understand what this object is and where it came from and whether its arrival in our solar system is random chance or something else entirely. After that, it's gone. And whatever questions we didn't answer, whatever data we didn't collect, whatever observations we didn't make, we'll never get another chance. The broader implications. Let's step back for a moment and consider what it means if 3I/Atlas is artificial. Not just for astronomy, not just for science, but for everything. For how we understand our place in the universe. For how we think about intelligence and technology and the possibility of contact with other civilizations. If 3I/Atlas is a probe, if it was built and launched by an intelligent species, it means we're not alone. It means somewhere in the Milky Way, at some point in cosmic history, another civilization arose. They developed technology. They built spacecraft. They sent those spacecraft out to explore the galaxy. And one of them arrived here. That civilization might still exist. They might be thriving on a planet hundreds of light years away, watching data stream in from 3I/Atlas as it reports back about its observations of our solar system. Or they might be gone, extinct for millions or billions of years. The probe might be a ghost, a relic, the last remaining evidence that they ever existed. We don't know. We can't know from the probe alone. But either way, it changes everything. It means intelligence is not unique to Earth. It means the universe has produced, at least twice, here and there, the conditions necessary for complex thought, for civilization, for technology. And if it happened twice, it probably happened many times. Thousands of times. Millions of times. The galaxy might be filled with civilizations at various stages of development, separated by vast distances in time, but all following similar trajectories from primitive life to intelligence to technology to space exploration. Or maybe not. Maybe intelligence is rare. Maybe Earth and one other civilization are all that ever emerged in the entire Milky Way. And maybe that other civilization is now gone, leaving only their probes wandering the darkness. That possibility is almost more lonely than being unique. Knowing we had cosmic neighbors once, but missed them by millions of years. There's also the question of intent. If 3I/Atlas is a probe, what is it doing? Observation seems likely. Gathering data about stellar systems, planetary environments, perhaps searching for signs of life or intelligence. But observation for what purpose? Scientific curiosity? Strategic intelligence? Precursor to contact? Precursor to something else? The object doesn't appear to be communicating, at least not in ways we've detected. It hasn't transmitted signals toward Earth. It hasn't attempted interaction. It simply passes through, observing silently, recording data for purposes we can't determine. That could be reassuring. It suggests non-hostile intent, pure research rather than reconnaissance for invasion. Or it could be unsettling because we have no idea what criteria it's using to evaluate us. No idea what it might report back to whoever or whatever receives its data. And then there's the possibility that it's not alone. If one civilization built interstellar probes billions of years ago, others probably did too. 3I/Atlas might be one of thousands of such objects wandering the galaxy. Most pass through empty space, never encountering anything interesting. But a few, by chance or by design, arrive at systems with planets, with life, with intelligence. This might not be humanity's first encounter with such an object. It might just be the first one we developed enough technology to detect. Ancient cultures have stories, myths about objects in the sky, about visitors from the heavens, about lights that moved in ways stars and planets don't. Most of those stories are probably just mythology, cultural narratives with no basis in actual events. But some of them, maybe a few, might be cultural memories of previous probes passing through. Objects that ancient peoples saw but couldn't explain. Objects that became gods or demons or omens in their stories. Objects that we're only now, with modern astronomy, finally able to recognize for what they might actually be. These are the implications. These are the questions that cascade outward from the simple fact of 3I/Atlas's existence. And they're why space agencies might be taking their time. Why they might be coordinating carefully. Why they might be very, very certain before they say anything publicly that suggests this object might be artificial. Because once you say it, once you open that door, you can't close it again. The world changes. Permanently. What comes next? So where do we go from here? What happens in the coming weeks and months as this story continues to develop? Here's what to watch for, what to pay attention to, what signals might tell us which direction this is heading. First, watch for official statements from space agencies. If NASA, ESA, CNSA, or the UAE release anything about 3I/Atlas, read it carefully. Not just what they say, but how they say it. Careful language, qualifications, phrases like preliminary analysis, or ongoing investigation, or further study required. These are signals that they're seeing something they need time to understand. Second, watch for scientific papers. When researchers publish findings in peer-reviewed journals, those papers go through detailed review. The language is technical, the conclusions are measured, but the data is there. If papers about 3I/Atlas start appearing in journals like Nature, Science, or the Astrophysical Journal, read them. Look at the data tables. Look at the spectroscopy. Look at what they're reporting and what they're carefully not saying. Third, watch the reemergence in November. Multiple astronomy groups will be tracking 3I/Atlas when it comes out from behind the sun. Amateur astronomers will post observations online. Professional observatories will publish data. If the object is where it should be, on the trajectory it should be on, that's significant. If it's not, if something has changed, you'll know within days because people will be talking about it everywhere. Fourth, watch for leaks. Space agencies employ thousands of people. Scientists, engineers, technicians, administrators. Not all of them agree with information control policies. Not all of them think withholding data is appropriate. If observations from October 3rd show something genuinely anomalous, someone might leak it. Anonymously, carefully, but leak it nonetheless. It has happened before with other controversial data. Could happen here. And finally, watch for silence continuing. If weeks turn into months and we still don't have detailed data from the Mars flyby, that itself is informative. It means whatever was observed requires extended analysis. It means agencies are being extremely careful. It means this isn't routine. The cosmic perspective. Before we conclude, I want to zoom out one more time. Beyond 3I/Atlas, beyond the specific object, to the bigger picture of what interstellar visitors tell us about the universe. We've now detected 3 confirmed interstellar objects. Oumuamua in 2017, Borisov in 2019, and 3I/Atlas in 2025. 3 in 8 years. That detection rate, combined with estimates of how much sky we're actually surveying and how many objects we're probably missing, suggests something remarkable. There might be thousands of interstellar objects passing through our solar system at any given time. Thousands. Most are too small to detect. Most are too dim. Most pass through the outer solar system, beyond Jupiter, beyond Saturn, where our telescopes rarely look. But they're there. A constant stream of visitors from other stellar systems, bringing with them material, chemistry, maybe information from across the galaxy. Our solar system isn't isolated. It's embedded in a river of interstellar objects flowing through the galactic disk. We're just now developing the technology to see that river. And if even a small fraction of those objects are artificial, if even 1 in 10,000 is a probe rather than a natural comet or asteroid, then our solar system is under constant observation. Not threatening observation necessarily, just documentation. Recording. A galactic survey that's been running for billions of years, cataloging stellar systems, planetary environments, the emergence and evolution of life wherever it appears. That's the cosmic perspective. We're not alone in empty space. We're embedded in a network, a web of objects and information flowing between stars. Most of it natural, the debris of planetary formation and stellar evolution. But some of it perhaps intentional, purpose-built, sent by intelligences we've never met and might never meet, simply to record the fact that we're here. Final thoughts. We started this journey with a simple image. Perseverance Skycam, October 2nd, 2025. A dot in the Martian sky. And we've traveled through mathematics, chemistry, orbital mechanics, international space policy, ancient mythology, cosmic philosophy, and unanswered questions that might not have answers. 3I/Atlas is still out there right now. As you listen to this, as you sit wherever you are, that object is moving through space at tens of kilometers per second. It's heating up as it approaches perihelion. It's outgassing. It's changing. And in 22 days, it will pass behind the sun, hidden from view, experiencing whatever it experiences during that closest approach. We don't know what will happen. We don't know what it is. We don't know if the silence from space agencies means something extraordinary or just bureaucratic caution. We don't know if the nickel signature is industrial process or exotic chemistry. We don't know if the trajectory is targeting or coincidence. But we know it matters. We know 7 spacecraft observed it. We know the data exists. We know space agencies are coordinating their response. And we know that in the coming weeks and months, as more information emerges, as perihelion passes, as the object reemerges and continues toward Jupiter, we're going to learn more. Maybe we'll learn it's just a comet. Unusual, fascinating, scientifically valuable, but natural. A messenger from another star system carrying chemistry we've never seen, teaching us about planetary formation in different galactic environments. Or maybe we'll learn something else. Something that changes everything we thought we knew about our place in the universe. Something that makes us reconsider whether we're alone. Whether we've ever been alone. Whether cosmic visitors have been passing through all along and we just didn't have the technology to recognize them. Either way, the story isn't over. It's just beginning. And whatever comes next, we'll be here to examine it, to question it, to understand it as best we can. If you've made it to the end of this journey, comment "watched it all" below. Let me know you were here for the full investigation, that you value depth over sound bites, that you're part of a community that doesn't accept easy answers when complex questions deserve complex examination. Hit that like button one final time. Subscribe if you haven't already, because this story will continue developing and you'll want to be here when new information breaks. Share this with anyone who values real analysis over headlines. And most importantly, keep watching the sky. Keep asking questions. Keep demanding answers. Because somewhere out there, 3i/Atlas is still moving. Still carrying its secrets. Still heading toward a moment 22 days from now when it will be completely hidden from us. And when it reemerges, we'll finally know whether our questions were the right ones to ask. Thank you for spending these 2.5 hours with me. Thank you for engaging with complex ideas. Thank you for being the kind of person who wants to understand rather than just consume. This community exists because people like you exist. People who think. People who question. People who refuse to accept "just trust us" as a sufficient answer. The next video is appearing on your screen right now. Keep exploring. Keep questioning. And I'll see you in the next investigation.